I went up to 330, now I'm 138.
All right. Evaluate with a calculator. 2 over 4. That is to the negative 5/2 power. Okay, so this is a number. There's no variables in here. It is equal to something else, and we are going to evaluate it by working straight down, okay? So, of course, the first thing that you're going to see in the bottom of the exponent is the negative. When you're trying to evaluate something, it's easier to get rid of negative exponents and fractional exponents because we don't really think that way, right? If I ask you the square root of 4, you're like, it's 2. But if I say, what's 4 to the 1/2, you're like, what? You have to think a little bit. So putting it back into radical form is what we want. So to get rid of the negative exponent, what do I do with the 4? Bring it to the top, right? So the 2 is there. I bring the 4 to the top, and what happens to the sign of the exponent? It changes, right? So because it was negative in the bottom, it's now positive 5/2 in the top. And what does that leave in the denominator? Not nothing, a 1, which we really don't need to write. Okay, good. Now, 4 to the 5/2. Remember, we can either say that's 4 to the 5th and then take the square root. What is 4 to the 5th? A big number. So we said yesterday, maybe it's better if we go small first. So that's the same as the square root of 4 to the 5th power. So let me write it like that. The 1/2, which is the 2 in the denominator, becomes the square root, and then we will raise that answer to the 5th power. Okay, so what is the square root of 4? 2. So that becomes 2 to the 5th. And at this point now you have 2 to the 1st times 2 to the 5th, which is 2 to the 6. Okay, so you could leave it like that, but that's still a relatively small number. So anyone know what 2 to the 6 actually is? 64. Yep, 64 is the final answer. Good. Now, 2 to the 5th is one of those numbers that's going to be showing up quite a bit throughout the year. So you should probably just memorize that 2 to the 5th is 32. 2 to the 5th is 32. And then you could go from there. So if I wanted to know what 2 to the 7th was, you wouldn't have to start at 2 to the 1st. You could just say, oh, it's 32 times 2 times 2, right? 128. Yes? Because we talked about that yesterday, if I wanted to do it this way, that's also correct. Yeah, that's also correct. But the order of operations there is different, right? What is 4 to the 5th power? It's a big number, right? It's like I don't care, right? That's what it is, right? If you know it, that's great. But I don't care because I'm not going to do it that way. It's the same as doing this. So that's part of that strategy that we were talking about yesterday. Go small before you go big instead of big before you go small. So I wrote it like that specifically so that I would be taking the square root of 4 first. Okay? Any other comments or questions on that? I really don't not care what 4 to the 5th is. Just not at this moment. Maybe this weekend I'll care a little bit more. I'll sit down with 4 to the 5th and apologize. All right. Everyone good? Yes, all right. Well, let's move on then. We were summarizing things in this table, and we're down to number 5, I think. If we have multiple factors, not terms. Remember, terms are separated by plus or minus signs. If we got multiple factors raised to a power, then each factor gets that exponent, okay? So again, you can pretend like there's little ones there, and we multiply m times 1, m times 1. All right, but they don't always have to be 1. So for example, let's look at this. The quantity 3x squared y cubed. If I want to expand it out, most students are going to be like, oh, okay, I got this. 3 times 2 is 6, so I got that. That's y, so it's going to be y cubed because it's really y to the first. But in haste, guess what? If there's going to be a mistake is made. Students, instead of putting 3 to the first and multiplying the 3 times 1 to get 3 cubed, which is 27, guess what the common mistake is? To call it 9. Yeah. In haste, they're like, ooh, I know I have to multiply that 3, So 3 times 2 is 6, 3 times 1 is 3, and 3 times 3 is 9. Oopsie. And guess what an answer choice is going to be on the test if this were a test question? 9x to the 6y cubed. And if you take that, I'm going to reel you in, and I'm going to say, don't do that, and I'm going to throw you back in. Okay? After the test, though, after you lose points. So be very, very careful. That's why I keep saying help yourself, help yourself. If you know you're distributing the 3 exponent to other exponents, simply put a target there for all the other factors, okay, to avoid a careless mistake. It also works with division, okay? When you're dividing and you have multiple factors, then every factor still gets the outside exponent, okay? So like 2 over 3 to the 4th is 2 to the 4th, 3 to the 4th. So real quickly here, do this one. Do a 5x cubed y squared over z to the 5th, all to the, let's see, 3rd power. Yeah, go ahead and expand that out real quickly. This is using those last 2 rules, combination of those last 2 rules. Hey, that'll work. Yeah, yeah. Go ahead and try and expand your number. It's relatively small. It's good practice for you to expand it. If it were like 5 to the 15th power, of course, we would leave it like that. Help yourself, help yourself. Avoid careless mistakes. Okay, so let me count. Inside I have 1, 2, 3, 4. I have 4 factor groups. These only work with factors, not terms. So I'm going to distribute the exponent of 3 to the exponent on all 4 of the factors. Well, 3 of the 4 factors have visible exponents. The first one does not, so I am going to drop in a 1 right there. And now I have a target for my 3. So it's going to be 5 to the 1 times 3 is 3, x to the 3 times 3 is 9, y to the 2 times 3 is 6, and z to the 5 times 3, which is 15. And if you simplified that, 5 cubed ends up being 125. So 125, x to the 9th, y to the 6th, all over z to the 15th. And if this were a test question, that's what I would have as the answer choice. What would be another answer choice I would have on the test? 15, x to the 9th, y to the 6th, z to the 15th. Excellent. See? So knowing the common mistakes, you could probably write the test question yourself. And if you can write the test question yourself, you're certainly going to know to avoid them when you actually take the test. That's excellent, okay? If you know what the common pitfalls are, you can take deliberate efforts to avoid them. Okay? Sweet, sweet, sweet. All right, so let's look at negative exponents. We kind of saw that in the warm-up. If you have a negative exponent on a factor, not a term, on a factor that's multiplied or divided, you could take it to the other side of the fraction as long as you change the sign of the exponent. So b to the negative n is 1 over b to the positive n, because that's really over 1. You can bring it down to the bottom, okay? So we're going to practice that. Let's go ahead and do that on example 2. It says simplify the following. We want to get rid of the negative exponent, okay? That's kind of what we're tasked with here. So 2 over x to the negative 4th. I want to get rid of the negative exponent, so I have the x in the bottom. I'll just bring it to the top. The 2 is already there, so I get 2x to the positive 4th, and that's it. Okay, we're done. That's very similar to the warm-up. Okay, Letter B, go ahead and do that one on your own. Get rid of the negative exponent, rewrite it without the negative exponent. Bless you. Coughs deserve to be blessed as well, don't they? Ooh, I'm seeing a lot of people on part B taking the bait and some that are not. Okay. This is where you got to be very, very, very careful. What is the base that has -2 as the exponent? Just the x. See that? Just the x. What is the exponent on the other factor of 3? It's a +1. If you want to put this over 1, so you have a denominator, it is only the x then that we're going to bring to the bottom. The 3 stays in the top, and we get x squared. Okay? You got to be careful. Unless there were parentheses around the group, you always have to be careful and say, all right, it is only the base immediately to the left of the exponent that is affected. Now, if you were heck bent on bringing the 3 to the bottom, right, you would be left with the 1 in the top. You could do that, but that would be 3 to the what in the bottom? Negative first, okay? And that just looks funny, okay? It's correct, but it looks funny. So this is what we're trying to do. Hey, speaking of grouping symbols, look at part C. What is the base now that has the exponent of -2? The quantity 3x, right? So I'm going to put that over 1, and I'm now going to bring the quantity to the bottom. And remember, when there's nothing left in the top, there's just a 1. Yeah, very good. If you know you're bringing the quantity to the bottom, but you write it like that, now it's not correct, because now you're not going to get that 3 involved with the exponent. So make sure that your grouping symbols are there when you need them, okay? Now that's good in terms of getting rid of the negative exponent, but I think we can go ahead and expand this out. What is 3x quantity squared? Well, it's 3x times 3x, which is 9x squared. Or you can use the rule of exponents that we just had. You could say, okay, that's 3 to the first, x to the first. So if you distribute the 2, you get 3 squared x squared. Okay? Either way. Either way. So if this, again, were a test question, 1 over 9x squared would be the answer. Or if this were a worksheet multiple choice question, 1 over 9x squared would be the answer. All right, so that's how you know when to stop. If it's a multiple choice question, you're like, how do I know when I'm done simplifying? Well, when you match it up to one of the answer choices, okay? All right, letter D. Oh, that looks too hard. I don't want to make a mistake in front of y'all, so I'm just going to let y'all do it. Go ahead. Inch by inch, it's a cinch. Mile by mile, it's a trial. You got this. No, I don't want to scare you. I want to give you confidence.
No, that's the opposite. I don't know.
I'll take a step back.
Okay, all right. No, now I'm even more nervous.
No. Just you got this. What do you do there?
Yeah, that's one. Well, I know like Dad has to
So what do you do with those?
like, but I don't know if it'd be Dad or.
Yes.
It would? Okay.
Get rid of this. You get rid of the 42.
Yep. And now combine your y's.
Oh.
Yeah. When you simplify here, you really want to have like one representative factor of each type. So in this problem, we have numbers and we have y factors. So in the end, you should have like one number, maybe to a power, and one y, maybe to a power, like that. Yeah, good. Now, if the number doesn't simplify, your number might end up being like 4/3 or 2/5. But I think this one does simplify pretty nicely. All right, so here's what I would notice. I would notice that I have one term. There's no plus or minuses, but I have how many factor or factor groups? Let's take inventory. I got a 4, a y cubed, a 2, and a that guy. So I have 4 factor groups. Our goal is to simplify. So if you have any radicals, write them as fractional exponents. Do we have any radicals in this one? Nope. The next thing you want to do is try to get rid of parentheses, grouping symbols. Do we have parentheses? Yes. Okay. So I'm going to go ahead and just see if I can focus on that. Okay. I'm focusing on this part right here. When I raise a power to a power, I multiply. So that's going to be y to the 8th. Good. Now the y cubed in the top is just going to be sitting pretty. Now you could go ahead and write 4 in the top and 2 in the bottom. That's fine. But in this case, I have focused my attention on the y's. When I go from one line to the next, now you can also then pay some attention to the numbers. What is 4 divided by 2? 2. So I'm just going to go ahead and simplify that and put a 2 in the top. All right? Take more lines if you need to. If you're going to do this in like 10 lines and do little bitty steps along the way, as long as you're getting the right answer, that's fine. You need to be effective first. Okay? That is, get the right answer. But once you become effective, then you want to strive to be efficient. Okay? And that means kind of doing it in fewer steps if you can. All right, so there's one last thing to do. I have a couple of y factors that I can combine. And there are a couple of ways to do it. The first way to do it is to use the rule from up above that says when you are dividing and the bases are the same, you subtract the exponents. When you do that, the result is always in the numerator, okay? So I'm going to write that as 2 times y to the, and then let's do the subtraction. What is 3 minus 8? -5. So you get 2y to the -5th. And that's correct, but it has a negative exponent. So if you want, you could bring the negative back down to the bottom, leaving the 2 in the top because it has a +1 exponent, and call it 2 over y to the 5th. And that would be the final answer. Now, that's one way to do it. Another way to do it is just to kind of take inventory, right? You have 3 factors of y in the top and 8 factors of y in the bottom. So there's more factors in the denominator, yes? But 3 of them are in common, so 3 of them will divide out, leaving how many left in the bottom? 5. And so you can go straight from this step to that step. That's fine too, all right? But the rule works. Top minus bottom, it just gives you a result in the numerator. So there it is, 2 over y to the 5th, right? It's fun when you know how. Okay, so just to review then fractional exponents. B to the m divided by nth power can be written 2 ways, right? The nth root of b to the m, and that would be kind of what you asked earlier. You're going to be raising it to a power of m first, and then taking the nth root, or the nth root of b first, and then to the mth power. They're both okay, all right? Part 3, simplify the following expressions if possible. Let's see, a, b, c, d, e, that's 5. I'm going to give you 5 minutes to do these on your own. And then let's see who can get all the way through E, and then we'll go through them. On your marks, get sets, 5 minutes. I'll see you in 5 minutes. If you get stuck, talk to a math buddy. Collaborate. Talk it through together. Go, 5 minutes. Example 3. This would be a good time to play that Lori Morgan song, that country song. You got 5 minutes to figure it out. Ooh. But it's not on Spotify. I already looked. If you get stuck, skip it and go to the next one. Inch by inch, it's a cinch. And remember, rewriting radicals for variables as fractional exponents is a good way to start. If it's a number, we want to leave it in radical form so we can evaluate it. Possibly. Explore your options. Don't be afraid to try something and see if it works. If it doesn't, that's a lesson to be learned as well. Fractional exponents. Not 4/2, 2/4, part A? Right? Why? Remember, roots are underground. Roots are underground. That's what it ends up being, yeah. But show your steps. Remember, roots are underground, right? We call that the fourth root. So when you write it as an exponent, it's in the denominator. Roots are underground for the most part. It sure is.
I'm not gonna say it out loud because I don't want to be wrong.
No, well, just don't want to give it away.
Oh yeah.
Yeah.
What?
Because 2 squared is 1.
I'm so lost now.
I didn't follow that. I'm sorry. What?
Yes. Square the 2 into 1.
No, the square root of 2 though isn't 1. No, it's like 1.4 something. Yeah. Right. Half of 2 is 1, but the square root is not.
Are we gonna have basketball?
The fun really ramps up really quickly here. We review a basic example, and then it's like, now that we know that, let's add some spice to this. All right, that's 3 minutes. We got 2 more before we go over it. If you don't get all the way through, that's fine. This is not a race. We're still practicing. Let me see. Go back to C or B. Sorry, no, C. C was the one. Yeah. What'd you get? Yeah. Good. So here's just kind of what I'll be saying in a little while. If we start as a radical, we want to kind of end up in radical form. So that's the right answer. But can you put that back in radical form? There you go. Perfect. You got this. You got it.
I don't know. I'm Asian, but I don't know this.
That's hard.
That doesn't make sense.
Okay.
Skip it. Skip it. When you're stuck, skip it.
No. Isn't that like a bad idea?
Hey, invite
50 seconds and we go over it. Are those shoes called quatrefoils? Is that the name of them? No? They're like permanently shiny, right? You didn't have to shine them? Yeah. Look sharp. Oh, thank you. Lieutenant. Hey, tell your stepdad I said hi. Okay? Yeah, he and I used to do trampoline wars back in the day. Yeah. Tall guy. Oh, at parties when there was a trampoline, we would do trampoline wars, like to see who would break each other's arm first. Yes. Yeah. Okay, let's go over it. All right, number 3. We got 3 times the 4th root of x squared. The 4th root of x squared, that's a variable in radical form. Let's go ahead and rewrite it as x to the 2/4 power. Now, a word on that. I kind of want you to be able to go straight from the 4th root of x squared to x to the 2/4. But here is the intermediate step if you wanted to see it. That would be x squared all to the 1/4 power, right? And then you would multiply 2 times a 4th. So see if you can just practice going straight to 2/4. Now, it's easy to see that, hey, 2/4 is the same as what? 1/2. So 3x to the 1/2 is a fine place to stop, but here's kind of a rule of thumb. If it's an expression with variables, if it starts in radical form, we want to end it up in radical form. Putting it as rational exponents is just a medium to help us simplify it. So if I put it back in radical form, what goes under the square root? Just the x. Good. The 3 remains outside. Some people at the end kind of lose it and they put the square root of 3x. It's 3 times the square root of x. I would consider both of these equally simplified, okay? All right. Questions on A? So good so far, so good? All right. We be in here till 10:25. We got plenty of time. Letter B. 4 over the 5th root of 2 to the 5th. Oh, my goodness. Okay. This is a number. So there's no variable, so this might simplify down to another number. Now, same thing I did over here. It worked. Let's put everything in radical form. I'm not sure quite yet what that's going to do for me, but I can reevaluate after that step. So the square root of 2 to the 5th is the same as 2 to the what power? 5 halves. Okay? Because remember, the 5 is already in the numerator. It's like 5 over 1. But because it's an implied 2 here for the square root, the 2 root is in the denominator underground. Well, I heard people saying 2 to the 5th is 32, and that's correct. But remember, I'm trying to combine things, and I have a base of 5, which is prime. I have a base of 2, which is also prime. But 4 is not prime, is it? In fact, I can write 4 as a power of what number? 2. So this is where your clever radar is out there going, ooh, 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 right? And I'm going to write 4 as 2 squared. So it's 2 squared over 5 times 2 to the 5 halves. Okay? New column. Now I have bases that are the same. And what do I do with the exponents when the bases are the same? Subtract, okay? Now notice the 5 is in the denominator, so I'm going to build the shelf, okay? And I'm going to put the 5 in the bottom, and I'm going to put the 2 in the top. So here's what I have to do. I'm going to do this off to the side. I need to come up with 2 minus 5 halves. You are going to become so good with fractions in this class because you're going to have lots of opportunities to work with them without a calculator, okay? So 2 minus 5 halves. Here's how you need to look at that. You need to say, okay, if 5 halves is a fraction and it has a denominator of 2, then I need to get the whole number 2 to be something halves, right? Something over 2. So 2 is how many halves? It's 4, right? You get 2 whole pizzas, right? And you cut each pizza in half. How many halves are you going to have? 1, 2, 3, 4. And then you eat them all, right? Yummy. So 2 is the same as 4 halves, okay? Now what's 4 halves minus 5 halves? Negative 1/2. Very good. Here's what's happening behind the scenes. I want you to be able to do it in your head, but here's what's happening behind the scenes. Your teacher in little school said, put this over 1. The common denominator between 1 and 2 is 2. You're going to multiply this first one by a clever form of 1 known as 2 over 2, because that doesn't change the value. It's equal to 1. Now, that's going to give you 4 over 2 minus 5 over 2. And now, because the denominators are the same, you could put it all over the same denominator, and you get 4 minus 5. And of course, 4 minus 5 is negative 1. So you end up with negative 1/2. That's what you need to be able to do in your head. How are you going to be able to do it in your head? A little bit of practice. If you need to go off to the side and do it there to begin with, that's fine. Now notice I worked from left to right here instead of down because I didn't have the room. So that's going to be 2 to the negative 1/2 power. Okay? 2 minus 5 halves. Again, here's how you want to do it in your head. 2 minus 5 halves. Okay, the denominator is 2, so let's multiply the whole number 2 by 2 to get 4. 4 minus 5 is negative 1, so I get negative 1/2. Okay? Now all we got to do is clean this up. We're going to do it in 2 steps now, but I want you to be able to do it in 1 step eventually. First thing we're going to get rid of is the negative exponent, okay? Because that's how you read the number, negative 1/2. Get rid of the negative first. So I'm going to bring it to the bottom, and now it becomes 2 to the positive 1/2. And what does that leave in the numerator now? A 1, not a 0, but a 1. Now that I got rid of the negative exponent, I am going to get rid of the fractional exponent. So 2 to the 1/2 is the same as what? Square root of 2. And there's your final answer. Okay? Wow. So if this were a test question, it seems so simple, right? It would say, which of the following is equivalent to this? And this would be your answer choice. So how do you know when to stop? Well, you know when to stop when you see your answer there. Okay? Now, what I want you to be able to do eventually is to go straight from here to here. Okay? I want you to be able to look at a negative exponent and say, the negative is going to bring it to the bottom, and the 1/2 puts it back under the radical. And you go straight from 2 to the negative 1/2 to 1 over the square root of 2. Eventually. Practice like that. When you're doing your worksheet, force yourself to make some of those jumps, okay? Now, did y'all ever have a teacher that said at some point that radicals in the denominator are bad? No one's had that? Yes, maybe? Okay. They're not bad, but some teachers think they are. There is a reason why sometimes we don't want them there. But if you did have to rationalize the denominator, y'all might have heard that in Algebra 2, you would multiply by the square root of 2 over the square root of 2, which is really equal to what? 1. And here's what would it become. 1 times the square root of 2 is the square root of 2. And on the bottom we get 5. And then what is the square root of 2 times the square root of 2? It's 2, right? Because it's really the square root of 4. And so that's 2. And then what is in the denominator 5 times 2? 10. So that is another version of the right answer. Okay? If this were a test question or a worksheet question, and you got all the way down to 1 over 5 square root of 2, and you look for your answer choices and they're not there, but you see some of your answer choices have a radical in the numerator, guess what you would probably want to do? Rationalize it to get that answer. Again, that's the purpose of the multiple choice questions, to possibly force you to go to a point beyond where you normally would. If this were a short answer or a free response, you could stop right here. So again, make sure that you're doing your worksheets with that in mind. You're taking them very, very seriously. That is your practice. And I'm not there like a coach on the court or on the field, running you through the drills. I'm basically doing the drill with you once and saying you got to go home and do the rest on your own, okay? So you have to be disciplined. All right. Questions on B? Is it legal to have this much fun in here? Maybe not, but Officer Butcher's not here, is he? All right. Part C. No one's going to P3 me for doing too much Precal, right? Okay. Part C. I have the square root of x times the cube root of x. I want to put them together. They're in radical form. What should we do if we see something in radical form and we're trying to simplify it? Change it to the exponent form. Good. So the square root of x is the same as x to the 1/2 power. The cube root of x is the same as x to the 1/3 power. Okay, good. Now that the bases are the same and we are multiplying, what do we do with the exponents? We add them. So it's going to be x to the, I'll write it out here, 1/2 plus 1/3. And now you're like, oh boy, oh boy, oh boy, I get to work with fractions once again. So, does anyone know just off the top of your head what 1/2 plus 1/3 is? 2/5? No. We can't just add straight across. We can only multiply straight across. We don't add straight across. In order to add fractions, we need a common denominator. 5/6. Okay, good. The common denominator between 2 and 3 is their product because their only common factor is 1. We call those numbers co-prime. Can y'all remember that? Two numbers whose only common factors are 1 are co-prime. Numbers then that are co-prime have a common denominator or a least common multiple, LCM, that is their product. Let's see what that would look like off to the side. If you were in little school, 1/2 plus 1/3, you need a common denominator. It's 6. So this one has the 2, it needs the 3, so you'd multiply by 3 over 3. This one has the 3, it needs the 2, you'd multiply by 2 over 2, and that gives you 3 over 6 plus 2 over 6, which is 3 plus 2 now all over 6, or 5/6. Okay? This is the type of question I usually ask my waiter or waitress at a restaurant. Okay? I'd say, what's 1/2 plus 1/3? And they'd be like, would you like more chips and salsa? And I'm like, absolutely. But what's 1/2 plus 1/3? And they walk away. Okay? It's real easy to do in your head if you remember this little rule. This is called, what, for lack of a better term, I call it the crisscross applesauce butterfly multiply method. Yeah? When your values are co-prime, here's how you can get the answer in your head with a little bit of practice. You start in the top left always, and you multiply down. What's 1 times 3? 3. You hold that in your head. Then you take the middle sign, and then you multiply down the other diagonal. What's 1 times 2? 2. You hold that in your head, and then you add those together. So you're really just going 3 plus 2, which is 5, and then it's all over the product, 2 times 3. Okay? Got it? Let's try one before we leave for the weekend. What's 2/3 plus 5/7? Or we'll do minus 5/7. Quickly. Doing that crisscross applesauce. Top left, middle sign, other diagonal, all over the product. Two-thirds minus 5/7. All right, here.
29/21.
29/21.
Yeah. Right? Negative.
It's minus. It's subtraction. Okay, so here it is. You have to start in the top left. Watch. What's 2 times 7? 14. Minus, what's 5 times 3? 15. So what's 14 minus 15? -1 all over the product, which is 21. That's the answer, -1/21. Now here's why you have to start in the top left. If you started in the top right, you're going to get 15 minus 14. You're going to get the opposite of the right answer, okay? So as long as you start in the top left, crisscross, applesauce, butterfly, multiply. You can do it. All right, so to finish this one, we get x to the 5/6. And all we got to do is put it back in radical form. That's going to be the 6th root of x to the 5th. Remember, if it starts in radical form, it should probably end in radical form. All right, don't be afraid of fractions. When you see them in your worksheet, force yourself to try to do them in your head. And then check by going off to the side and doing what you did in little school, okay? All right, y'all have a fantastic weekend. Be loud at the pep rally. Don't leave me hanging, folks.